Leetcode 253, Meeting Rooms 2. You are given meeting intervals as start and end times. Return the smallest number of conference rooms such that every meeting can be scheduled without two meetings sharing a room while both are in progress. Example 1, intervals 0 to 30, 5 to 10, and 15 to 20. At time 5, the long meeting and the 5 to 10 meeting overlap, so you need two rooms. Output is 2. Example 2, 7 to 10 and 2 to 4. After sorting by start, the first meeting ends before the second begins, so one room suffices. Output is 1. In meeting rooms 1 we only asked whether any pair overlaps. Here we must schedule every meeting. If two intervals overlap, they cannot share a row on the timeline, so we stack one of them onto a second track. That extra track is an extra room. Here is the useful view: split every meeting into a start time and an end time. Sort all starts and sort all ends. You do not need to match which end belongs to which meeting for the count. A start means someone occupies a room, an end frees one. Same time ties are handled by processing ends before starts so a room can be reused. Sweep a vertical line across the day in time order. Whenever it passes a start, active meetings go up by 1. Whenever it passes an end, active goes down. Think of it like passengers on an elevator: starts board, ends step off. The minimum number of rooms equals the worst moment of overlap, not the total number of meetings. Track the maximum value the active count ever reaches. That peak concurrency is exactly how many rooms you need. First, pull every start time and every end time into two lists, and sort each one. You never need meeting IDs for this count, only chronological order of arrivals and departures matters. Place two pointers at the front of starts and ends. Compare the next start to the next end. Here the first start is 0 and the earliest end is 10. 0 is less than 10, so a meeting has begun before any meeting has finished. Open one room and advance the start pointer. The next start is 5, still before the earliest end at 10. A second meeting is running while the first is not over, so active goes to 2. That is peak pressure for this stretch. The next start is 15, but the earliest end is still 10. 10 comes first in time, so a meeting has finished, decrement active and move the end pointer. Then compare again: 15 is before 20, so the meeting at 15 opens a room again. Active returns to 2, not 3. You reused a room instead of opening a third. Keep advancing pointers until every start is handled. The largest value active ever reached is the answer. Here the high water mark is 2. Besides storing the sorted arrays, you only keep two indices and a couple of counters. Let n be the number of intervals. Time is order n log n. You sort all start times and all end times, then walk both lists with two pointers in linear time. A min heap of n times is another common n log n solution with similar time. Space is linear for the two sorted arrays of times, plus constant extra for pointers and the running max. Pseudocode for meeting rooms 2, handle an empty list with 0. Collect every start and every end, sort both arrays, then sweep with two pointers. If the next start is before the next end, another meeting is active, so raise the count and track the maximum. Otherwise an end came first, so decrement active and advance the end pointer. Return the best peak you saw.